Hello there, welcome to CSEC Math GT. Today we will be looking at the laws of indices. So we need to be able to perform and use the laws of indices to solve exponential equations with one unknown. We need to be able to solve equations reducible to a linear form. And we need to be able to use laws of indices to help us solve equations that can be reduced to a quadratic form. So what are the laws of indices? Indices is just a useful way for us of expressing large numbers. They also present us with many useful properties for manipulating these numbers. We just call all of this manipulation we're going to do the laws of indices. Alright, so in other words, we use the laws of indices to simplify expressions or solve equations with the same base. That's all we'll be doing. We'll be just trying to solve equations and simplifying expressions with the same base. So the first law that we're all familiar with, n to the p times n to the q, we know that is equal to n to the p plus q. So a lot of persons will tell you to remember this. When the bases are the same and we multiply, what we're doing is we just add the powers. For example, 5 cubes times 5 to the 4, that's 5 to the 3 plus 4, which is 5 to the 7. If you wanted to list it out, look at this. 5 cubed would be 5 times 5 times 5. Multiplied by 5 to the 4 would be 5 times 5 times 5 times 5. If you notice, if you were just multiplying 7 5s there, so it's 5 to the 7. So that's the first law of indices. Law number 2 tells us that n to the p divided by n to the q is n to the p minus q. In other words, when the bases are the same and we divide, we subtract the power. For example, 5 to the 6 divided by 5 to the 4, that would be 5 to the 6 minus 4, which is 5 squared. If you were to list it out, 5 to the 6 is 5 times 5 times 5 times 5 times 5 times 5. And 5 to the 4 would be 5 times 5 times 5 times 5. Notice that the 5 in black, all the 5s in black would cancel, and you'd be left back with the 5s in red. And 5 times 5 is 5 squared. Wow! That's the second law. The third law tells us that n to the p raised to the q is n to the p times q. In other words, we're saying that 2 cubed to the 4th power can be written as 2 to the 3 times 4, and 3 times 4 is 12, so that's 2 to the 12. If you don't believe me, look at it. 2 cubed is 2 times 2 times 2, and raising it to the 4th power means we're multiplying it by itself 4 times. So that's times 2 times 2 times 2 in blue, times 2 times 2 times 2, times another 2 times 2 times 2. Notice that we just be multiplying 2 12 times, so it's 2 to the 12th. Then law number 4 tells us that n raised to the 1 over r is the rth root of n. For example, 24 to the quarter is just the cart root of 24. 28 raised to the 1 over 7 is the 7th root of 28. Alright? And law number 5, it tells us that any number raised to the power of 0 is 1. So n to the 0 is 1. So for example, 21 raised to the 0 power, that's just 1. Alright? That's not 21 degrees there. That's 21 raised to the 0. Alright? Please don't misconstrue the 0 in the power as a degree symbol, please. And then law number 5 tells us that n to the minus p is 1 over n to the p. So 5 to the minus p is 1 over 5 cubed. 6 to the minus 4 is 1 over 6 to the 4. Law number 6 tells us that n to the p raised to the 1 over r, this is just the rth root of n to the p, or some persons might write it as the rth root of n raised to the p. In other words, we can say that 5 to the 3 over 2, you could write it as 5 cubed raised to the half, or you could write it as the square root of 5 cubed, or you could write it as the square root of 5 all cubed. Just depending on what the question is, you can manipulate it any way you want. Likewise, 7 to the 4 over 3 would be, you tell me, write it down. So it would be 7 to the 4 raised to the 1/3, or you can write the cube root of 7 to the 4th power, or you can say it is the cube root of 7 raised to the 4th power. So now, of course, looking at our objective, we're going to use the law of indices to evaluate some index question. Alright, so now we're going to look at some questions that you typically get in exams. Wow! So now we're doing some questions to utilize the law of indices. Alright, so this one says find the exact value of 64 raised to the 1/3 power multiplied by 216 to the 1/3 divided by 8. Now, the first thing is that, look at this, right? We clearly realize we're going to utilize this law. N to the P raised to the Q is equal to N to the PQ. Right? Clearly, because it's been raised to the 1/3 power, right? So we clearly see that we can utilize that law. So what am I saying? Let me just increase the font size. So what we're saying here then is clearly we can write down that 64 raised to the 1/3 power multiplied by 216 to the 1/3 power divided by 8. We know that 64 is what? 4 cube. So this is 4 cube raised to the 1/3 power multiplied by 216. I know that is 36 times 6. So in other words, that's 6 cube to the 1/3 power over 8. Now we can use this law of indices right here that tell us that n to the p to the q is n to the p times q. So this is going to become equal to 4 to the 3 times 1 over 3 multiplied by 6 to the 3 times 1 over 3 divided by 8. Now 4 to the 3 times 1 over 3, this 3 cancel this 3. So we're left back with just 4 to the 1 multiplied by, this is now, as we can see, 6 to the 3 times 1 over 3. That's just 6 to the 1 because this 3 cancel this 3 over 8. Wow! 4 times 6 is 24. So that works out to be 24 over 8. And 24 over 8 is 3. In other words, all of this works out to just be 3. Alright, using laws of indices. If you don't believe it, let's check it out in our calculator. So I'm going to put in 64 raised to the 1/3 power. Then I'm going to multiply it by 216 raised to the 1/3 power and divide it by 8. As we can see, put it in the calculator, we get our 3, which is absolutely beautiful, right? We did that without even using the calculator because we used the law of indices. Alright, so the next part now, part A and part B, I want you to pause the video and simplify both of those expressions for me using laws of indices. Alright, so as you pause the video and attempt to simplify, realize that part A, let's do part A in black. We have 8 to the 2x multiplied by, this is 2 to the 5x, and then we're going to divide it by 4 to the 6x. Now when you multiply, when the bases are the same, you add the power. So let's try to get everything in the same base so we can use law of indices. 8 is really 2 cube, and that's raised to the 2x, multiplied by, this is 2 to the 5x, divided by 4 is really 2 squared raised to the 6x. Then we know that n to the p raised to the q is equal to n to the p times q. So we can rewrite this part here now as 2 cube to the 2x. We can just rewrite that. What I'm saying is now we can rewrite that as 2 to the 6x, right? Where's my pen? So we can rewrite this here as 2 to the 3 times 2x is 6x, multiplied by 2 to the 5x, divided by 2 squared to the 6x. We can multiply the 2 times 6x to get 12x. Using that law down here. So we utilize this law down here. Alright, so in other words, this is going to work out to be 2 to the, when we are multiplying and they're of the same base, we add the power, so 6x plus 5x. Then when we're dividing, we subtract the power, so we subtract that 12x. 6x plus 5x is 11x, so this works out to be 2 to the 11x minus 12x, which is equal to 2 to the 11 minus 12 is negative 1, so that's 2 to the minus x. Or you can write it as 1 over 2 to the x. Alright, so this works out to be 1 over 2 to the x. Wow! That is option A. Really, really, really nice. Now part B. Part B, we need to simplify what is 16 raised to the 3 over 4x divided by 8 to the 5 over 3x. Then they put a bracket around it, and the result of that, we multiply it by 4 to the x plus 1. Again, we need to use law of indices, right? So we realize that we can put everything to base 2. So 16 can be written as 2 to the 4th power, and that's raised to the 3 over 4x, divided by 8 can be written as 2 cubed, and that's raised to 5 over 3x, multiplied by this 4 right here is really 2 squared raised to the x plus 1. We can then go ahead and simplify this to be, this is now 2 raised to the 4 times 3 over 4x, divided by 2 raised to the 3 times 5 over 3x, multiplied by, this is now 2 raised to the 2 times x plus 1 is just 2x plus 2. Wow! Yeah. So as we realize right here, this 4 cancels this 4. This 3 cancels this 3. So we're left with 2 raised to the 3x. And then we're dividing it by 2 raised to the 5x. But then we're multiplying it by 2 raised to the 2x plus 2. Now, when you divide, you subtract the power, so that's 3x minus 5x, and then you add the 2x plus 2. So when we simplify 3x minus 5x, that is minus 2x, so that's 2 to the minus 2x, but then we're adding 2x plus 2, that works out to be, all I did was work out this part here first to get the minus 2x. And then now when I add the 2x plus 2, that will become 2 raised to the 2, and 2 to the 2 is 4. So we're saying this expression right here simplifies just to be 4. Alright? That's the beauty of law of indices. Really nice so far. Wow! Nice. Now, the first one, notice we find the exact value. The next two is simplified expression. Now, what about when they give you a question like this to say, evaluate now, evaluate. Evaluate the square root of 3 to the 10 plus 3 to the 9 divided by 3 to the 11 plus 3 to the 12. Pause the video and attempt this question. Alright, now in order to do this, the first thing we realize is that let's not trouble the square root for now. We need to apply law of indices, right? So the square root has nothing on us. If we notice 3 to the 10 and 3 to the 9, both of them have 3 to the 9 in common, right? We can rewrite, look at this, 3 to the 10, we can rewrite it using law of indices as 3 to the 9 times 3 to the 1, right? Hey! So we can rewrite 3 to the 10 as 3 to the 9 times 3 to the 1 plus 3 to the 9. And then 3 to the 11 we can rewrite, well, let's keep the 3 to the 11 as itself. But then 3 to the 12 we can rewrite as 3 to the 11 times 3 to the 1. Now we can then factor out from the numerator what? We can factor out what's in common, 3 to the 9. So if we factor out 3 to the 9, we're left back with 3 plus 1. And from the denominator we can factor out what's in common, which is 3 to the 11. Then we're left back with 1 plus 3. But then guess what? 1 plus 3 is 4. So this 3 plus 1 cancels this 3 plus 1. So we're left back with the square root of 3 to the 9 over 3 to the 11, which is just 3 to the 9 over 3 to the 11. When you're dividing and the bases are the same, you subtract the powers. So that's 3 to the 9 minus 11. So all we're doing is we're finding the square root of 9 minus 11 is negative 2. So that's 3 to the minus 2. Wow! Yep. So now we end up have the square root of 3 to the negative 2. But this can be rewritten as 3 to the minus 2 is just what? 1 over 3 square. So we have the square root of 1 over 3 square. The square root of 1 is 1. And the square root of 3 square is what? 3. So all of this just works out to be 1 over 3. That's your answer. So this right here works out just to be 1 over 3. That's beautiful. Now let's take out our calculator and verify it, because sometimes, you don't necessarily believe it. So look, square root, we're going to put in 3 raised to the 10th power plus 3 raised to the 9th power, and we're going to divide that by 3 raised to the 11th power plus 3 raised to the 12th power. Put that in our calculator. There you go. 1 over 3. Wow! Really nice. Alright, now sometimes you'd be given equations to solve, and we have 4 of them. So I want you to pause the video and attempt this question here. Solve the equation 9 to the x is equal to 3 to the x plus 2 minus 8. So pause the video and attempt this question. Alright, so now you see this 9 to the x right here? We can break up 9 to the x as 9 is what? 3 square raised to the x. And that's equal to, now, using law of indices, 3 to the x plus 2 can be written as 3 to the x times 3 square. Right? We can write it as times 3 square minus 8. Now, anytime you see me put a dot represents multiplying. So now 3 squared to the x, right? Can't we rewrite that as 3 to the x being squared? Of course we can. Of course we can. Imagine n to the p raised to the q. That's just n to the p times q, which we can say it's n to the q raised to the p. We can flip it around, right? Because multiplication is commutative. So we just rewrote 3 squared to the x as 3 to the x squared. That's equal to 3 times 3 to the x minus 8. Now what if we were to just let m equal 3 to the x? Because that 3 to the x doesn't look too pretty, does it? The 3 to the x can be a little confusing. So if we call m 3 to the x, we're getting m squared is equal to 3m minus 8. So let's bring everything to one side. We end up have m squared minus 3m plus 8, and that is equal to 0. Now I hope you'd have been paying attention and realized that, but wait a second sir, why is that 3? This should have been 3 square. 3 square in front of the 3x. This should have been 3 square. This should have been 3 square m. And now we can tell them that 3 square is 9, of course. So that works out to be m square minus 9m plus 8 is 0. Now when you get to this stage now, you just need to factorize. Signs are the same, both of them negative. M, 8 and 1, minus and minus. So that is saying m is equal to 1 or m is equal to 8. Now if m is equal to 1, what was m again? M was 3 to the x. So 3 to the x is 1 or 3 to the x is equal to 8. If 3 to the x is equal to 1, then what we're then saying is that 1 is really 3 to the 0. So that works out just to be x equals 0. Alright? So x equals 0 is our answer. Now for this part now, 3 to the x is 8. The bases are different. So we don't get to this topic yet for now. So just take it as gospel and write that x would be log 8 over log 3. Now you might wonder, what is this log? We're going to cover this in the very next video, logarithms. But the two answers would be, when you solve this, what you'd get solving the equation, you'd end up get x equals 0 or x equal log 8 over log 3. Those are the two answers, all right? These are our answers that we would get. Now, I'm going to verify with one of them when x is 0. When x is 0, for example, look at it. When x is 0, you'd end up say that 9 to the 0 is 1. And on the right side, you'd say that 3 to the 0 plus 2 minus 8 would be 3 squared, which is 9, minus 8, which is 1. Notice that when x is 0, both sides of the equation giving us 1. So say that x equals 0 is true. So this is indeed our answer. Alright? Nice. So notice how we use laws of indices to solve an equation. The equation went from manipulating laws of indices to end up being a quadratic, to end up solving a quadratic. Alright? And this is known as a hidden quadratic equation. So let's do one more hidden quadratic equation. So pause the video and attempt this one for me, please. 2 to the 2x minus 9 times 2 to the x minus 1 plus 2 equals 0. Pause and attempt. Alright, so in doing this question, right, we notice we have 2 raised to the 2x. 2 raised to the 2x, we can write this as 2 squared raised to the x, and because multiplication is commutative, we can write it as 2 to the x squared. I hope we all see that. So in other words, we're saying this can be written as 2 to the x squared minus 9 times, in bracket, 2 to the x minus 1. That can be broken up as 2 to the x multiplied by 2 to the negative 1 plus 2 equals 0. No problem so far. This is then saying 2 to the x squared minus 9 times, in bracket, this is now 2 to the x, but multiplying by 2 to the minus 1. What did we say yesterday? What did we say earlier today? We said that 2 to the minus 1 is 1 over 2. So we can just put that being divided by 2 plus 2 equals 0. Now what if we were to just let m be equal to 2 to the x? Yeah? I like to use the letter m. So in that case, we'd have m squared minus 9 times m over 2 plus 2 equals 0. Now I don't like this fraction here, so we're going to multiply through the equation by 2 to get rid of the fraction. In other words, we're saying 2m squared minus 9m plus 4 is equal to 0. All we did was multiply each term by 2. 2m squared minus 9m over 2 times 2, the fraction gone. Then 2 times 2 is 4, and 2 times 0 is still 0. Now we can go ahead and factorize. This is saying signs are the same, both of them negative. So we have 2m and m. Alright, and we need to factor it so that signs are the same, both of them negative. So let's see, if we put 4 right here and 1 right here, and it says both of them are negative, minus and minus, would that work? 2m. Yes, this does work. Alright, this does work. And so what we're then saying is that 2m minus 1 is 0, or m minus 4 is 0. In other words, we're getting that m would be a half, or m would be 4. But if m is a half, what was m? M was 2 to the x. So we're saying 2 to the x is a half. And so in other words, we are saying 2 to the x is 2 raised to the minus 1. In that case, we're saying x equal to negative 1. Wow! And if m is 4, we are saying 2 to the x is equal to 4. And 4 is 2 squared. So we're saying 2 to the x is 2 squared. So in other words, we're saying x is equal to 2. So what are the answers? The answers are x is equal to negative 1 or x is equal to 2. Those are the answers. Really, really, really nice. Alright, so again, we realize that we went from using the law of indices, we manipulate it to get to a quadratic, and we solve the quadratic equation. Let's do a couple more.